Hello everyone, this is Xia. So in this new release of BEopt, we are having a vertical bore ground source heat pump. It is a water-to-air heat pump with a closed-loop vertical bore ground heat exchanger. It is the generic model that currently we only model single-stage compressor and a supply fan with a permanent split capacitor and cycling loop pump. There has been some limitations in both Energy Plus as well as though to properly model the dual-stage compressor operation. The references that we have on implementing the ground source heat pump has been we have IGSPA design and installation guide when it comes to the vertical bore ground heat exchanger design, taking ECA menu JNS load sizing results. And we also referenced ASHRAE ISO standard 13256-1 and also with manufacturer's performance curves. The sizing on the ground source heat pump is fully automated. However, it also has allowance for user inputs. If you have some, for instance, if you have some like site limitations on the number of bores or the bore depths, you can input those limitations, and BEopt will auto-size the rest. And also, if you go to the option editor, you can select design parameters such as fluid type, the pump pressure drop on the ground loop side, as well as delta T, design delta T on the ground loop side. The built-in options that I'll show in the next screen provide insight on energy versus cost, and we have permutations with system efficiency of EER and COP, as well as ground conductivity and ground thermal conductivity. This is a screenshot of the BEopt input screens, and there are 12 options of ground source heat pump with 4 levels of EER and COP. And talking about EER and COP here, these built-in options, EER and COP, are actually manufacturer-rated EER and COP. And BEopt will do calculations behind the scene to convert do a net to gross conversion from the unit to the compressor only, because both O2 and Energy Plus account for the fan and pump energy consumption separately. And also, we have 2 levels of ground conductivity as well as grout conductivity. The third column on the heat exchanger, the bore length varies with different climate. So actually, if you go to the site screen and change to a different climate, you will see the bore length in terms of feet per ton will actually vary. Last one is on the lifetime. So the lifetime is actually an effective average lifetime across representative continental climates, and it accounts for the unequal life of the indoor heat pump of 15 years, as well as the external ground loop life, which is 50 years. And also we have some default assumptions on the discount rate analysis period. So if a user decides to use a different analysis period and discount rate, these values will not be will not apply. So with some time limit, I'll just jump directly to the results screen. This is one sample project that I ran to demonstrate the effect of ground conductivity, as well as thermal efficiency on the source energy savings, as well as annual energy-related cost. So the top left corner, the graph shows the horizontal axis on the graph is the percent of source energy savings, and the vertical axis is the annual energy-related cost. And there are 12 options that was 12 points showing here. And points 1, 2, 3, 4 shows the 4 efficiency levels with low K soil, low conductivity soil, and standard grout. and 5 to 8 is low conductivity soil with thermally enhanced grout, and points 9 through 12 are the four efficiency, the four systems with high conductivity soil and enhanced grout. So, and also on the bottom right graph that shows the simulation results of these 12 options. So what the message we're trying to deliver with this result screen is that ground source heat pump can deliver the same or similar levels of savings if you properly size the ground heat exchanger. If you choose to use thermally enhanced grout or happen to be located in a site with high ground conductivity, it will result in less heat exchanger bore length, as well as pretty much resulting in reduced first cost and annual energy-related cash flow. So before I move on to the next screen, let me know if you have any questions.
Once again, if you would like to ask a question, please press *1. To withdraw your question, please press *2. One moment, please.
While we're waiting for questions, let me just maybe repeat a little bit what Cha said to emphasize a point. With the model in BEopt and the sizing that happens, so what we have here are units with increasing efficiency of the heat pump, and so that represents additional energy savings from left to right. The offset in these different groups are indicating that, sort of as Cha said, that if you change the soil conductivity or the grout conductivity, you're not seeing shifts here in terms of additional energy savings. What you're seeing is a change in the economics, because BEopt is auto-sizing the ground heat exchanger. So with improved soil properties or improved grout properties, what happens really is that you buy less heat exchanger, but you get the same performance, essentially, regardless of the change in those properties. So if you are looking, and so that's basically that this set of bars is indicating the efficient improvement in the heat pump efficiency, and then you see the same kinds of energy when we change the soil and the grout properties. So this result is the same as this, which is the same as this. So you're not going to see additional energy savings or a change in energy savings when you change, for example, the ground properties. But what you are going to see is a requirement for more or less ground heat exchanger and the significant change in cost associated with that. So that may be a little bit of a surprise that you'll change some properties expecting to see a difference in energy performance. Thing to remember is that that difference will show up economically, but not in terms of energy.
And also, one more point that I need to add is, speaking of the ground heat exchanger sizing, what's shown on the input screen is based on the peak design conditions only. However, behind the scene, BEopt is actually accounting for the annual net load unbalance and also doing a sizing adjustment based on that.
And I guess another point is that as with other new features that we've been describing today, if you remember, there's at the bottom of the option screen are what we call category notes, and those are helpful in describing some of the details of the modeling.